You check the weather app. It shows sunshine. Next day, rain. So it's easy to think, do meteorologists just guess? But modern weather forecasting is not guessing at all. It's one of the most data-heavy sciences on Earth. Today, forecasts are built using satellites high above the planet, weather radars, balloons that fly into the upper atmosphere, thousands of ground stations, and huge supercomputers that run physical models. Every single day, billions of measurements are collected and combined. From that, scientists calculate what the atmosphere is likely to do next. The atmosphere behaves like a moving ocean of air full of swirls, pressure changes, and temperature differences. If we know what it looks like now, we can try to calculate what it will look like later. If you like similar educational videos, please like, subscribe, and share the video with your friends. But it's far more complicated than it sounds. Meteorologists need to know where it's warm and where it's cold, how much moisture is in the air, how strong the wind is and where it's blowing, how the pressure is changing, how clouds are forming and moving. And they need that information from the entire planet almost all the time. In the next part, we'll look at where all these numbers come from and how they are actually measured. To predict the future of the atmosphere, scientists must first know its condition right now and as precisely as possible. That's much harder than it sounds, because weather is not measured in one place. It is measured everywhere. Ground weather stations. These stations sit in cities, villages, fields, and mountains. They constantly measure temperature, humidity, wind speed, and direction pressure, cloud cover, rain, and snow. They send new readings every few minutes. But they only tell us what happens near the ground. Oceans and seas. Most of Earth is water, and weather is strongly controlled by oceans. So scientists also use floating buoys, research ships, offshore platforms. They report temperature, wind, and pressure over huge empty areas where no people live. Weather balloons, radiosondes. Twice a day, thousands of weather balloons are launched across the world. Each balloon carries instruments that climb high into the sky and measure temperature, humidity, pressure, wind at many different heights. This lets meteorologists see what is happening inside the atmosphere, not just at the surface, crucial for storms, fronts, and jet streams. Weather radars. Radar sends out pulses of microwaves that bounce off raindrops and snowflakes. From this, scientists can learn where it is raining, how intense the rain is, how fast the storm is moving. That's why you see colorful rain maps on apps and TV. Satellites high above Earth. Satellites constantly watch the atmosphere from space. They show cloud movement, storm development, surface and atmospheric temperature, smoke, dust and volcanic ash, moisture patterns across continents and oceans. For the first time in history, satellites let us see weather as one global system, not just local snapshots. All of these measurements, millions every hour, are collected into giant databases. And only then does the magic begin. Supercomputers try to calculate the future of the atmosphere. In the next part, we'll see exactly how they do that. Once all the observations are gathered, supercomputers take over. This is where meteorology becomes pure physics and mathematics. The atmosphere behaves like a fluid. It flows, spins, rises, and sinks. Scientists use sets of physical equations that describe how air warms and cools, how water vapor turns into clouds and rain, how wind accelerates or slows down, how pressure systems form and move, how energy moves through the atmosphere. But those equations are incredibly complicated. No human could solve them by hand, so computers do it millions of times per second. This process is called numerical weather prediction. Imagine the Earth covered by a giant 3D grid. Each little box in that grid has information about temperature, moisture, pressure, and wind. Then the model asks, if this is the atmosphere right now, what will it look like 10 minutes from now? It runs the equations, updates every box, and moves time forward. Then it repeats. Again and again and again, stepping into the future. That's how we get forecasts hours, days, and sometimes weeks ahead. To improve reliability, meteorologists run multiple models, or even multiple versions of the same model. That's why one forecast may show rain, and another may show only clouds. The truth is usually somewhere in between. Why do forecasts sometimes get it wrong? Because the atmosphere is a chaotic system. A tiny error at the beginning, a slightly wrong wind measurement, a small storm that wasn't detected, or a slightly warmer ocean can grow into a big difference after a few days. The farther into the future we go, the more these uncertainties pile up. That's why short-range forecasts are usually very accurate, while 10-day forecasts should be treated more like scenarios than promises. In the next part, we'll talk about how meteorologists turn all these numbers into simple icons and what things like 30% chance of rain actually mean. When the supercomputers finish their calculations, the work is not finished. Now meteorologists have to interpret the results. A model does not write, tomorrow, 23 degrees Celsius, partly cloudy, showers in the afternoon. Instead, it produces massive tables full of values, temperatures at different heights, pressure fields, humidity, cloud cover, rainfall intensity, wind speed, and direction. Meteorologists then compare several models, check the results against radar and satellite data, remove clearly unrealistic scenarios, translate everything into language normal people can read. So every forecast is a combination of computers plus human judgment. What do the icons really mean? A sun icon does not mean guaranteed perfect weather. It means the models expect very low chances of cloud and rain. A sun with a cloud means variable cloud cover. A thunderstorm icon means a high chance of short, intense showers in the area. And what about 30% chance of rain? This is one of the most misunderstood numbers in weather apps. It does not mean 30% of the day will be rainy. It means this. On a given area, there is a 30% probability that measurable rain will occur during the given time. So it may rain only in part of the city, while other parts stay dry and the forecast is still correct. Why do forecasts sometimes change during the day? Because new information is constantly arriving. If radar shows storms forming faster than expected or satellites detect different cloud movement, the models are updated and the forecast changes accordingly. That isn't failure. That's science reacting to reality. In the final part, we'll see why forecasts today are better than ever and why they still will never be perfect. A few decades ago, forecasting the weather was closer to educated guessing. Today, thanks to satellites, radars, weather balloons, ocean buoys, and supercomputers, the situation is completely different. Short-range forecasts are usually very accurate. 3 to 5 day forecasts are generally reliable. Longer outlooks are useful, but more as guidance than certainty. And yet there is a hard limit we can't cross. The atmosphere is a chaotic system. Tiny differences in temperature, wind, or humidity can grow into completely different weather patterns days later. A small thunderstorm over mountains, a patch of warmer ocean, or slightly different wind direction can change everything. That is why meteorologists talk about probability, not guarantees. A forecast is not a promise. It is the best scientific estimate based on everything we know at the moment. And still, it's incredibly valuable. Forecasts help. Farmers plan planting and harvesting. Pilots and ships travel safely. Cities prepare for floods, heat waves, and snowstorms. Power companies manage electricity production. All of us plan our days, clothes, trips, and events. So when the forecast changes, it doesn't mean it was wrong. It means new data arrived, and the models updated the picture. That is science doing its job. Modern meteorology works like this: measure, calculate, check, improve, decide better. And the next time you open your weather app and see one tiny icon, remember, behind that symbol stands a whole global network of instruments, scientists, and computers, all trying to give you the best possible idea of what tomorrow will bring.